Let's look at differentiation of some trigonometric functions. We shall begin with the simplest. For example, sine x. The derivative of the sine x with respect to x is well known. Cosine x you can get from here to here from the first principle differentiation method. And of course, if y is cosine x, then dy dx is minus sine x. So we need to pay attention to this minus sign. What about tangent x? Now we know from definition tangent x is sine x over cosine x. So in order to differentiate sine over cosine x, we can apply the quotient rule that we looked at in our previous video. So first, to differentiate sine x, and we know that is quite simply cosine x, you multiply with the denominator, which is cosine x, minus, so this minus sign is embedded in the quotient rule. Now let's differentiate the denominator. So differentiating cosine x, we know it is minus sine x, multiply with the numerator, so that is sine x, divide by the square of the denominator, which is cosine x squared. So cosine x times cosine x is cosine x squared. Minus and minus will give you a plus. Sine x times sine x is sine x squared. So cosine x squared plus sine x squared equals to 1. That is just the identity of trigonometry, 1 over cosine x squared, which can be written as secant x squared, because 1 over cosine x is just secant x. Let's look at y equals to cosecant x. Cosecant x is 1 over sine x. So we can use the quotient rule again. Differentiating the numerator first, you get 0, because derivative of 1 is 0. Multiply with the denominator, sine x, minus, you differentiate the denominator, and that's going to give you cosine x, because derivative of sine x is cosine x, and then you multiply that with the numerator, which is 1, and divide the entire thing by the square of the denominator, sine x squared. And you get minus cosine x over sine x squared, which you can simplify by writing in this manner, breaking up into two factors. So you have the first factor, cosine x over sine x, and 1 over sine x. So minus cosine x over sine x is cotangent x, and 1 over sine x is cosecant x, and that's the answer. Let's look at the following function. It involves power, and we can use the technique of differentiating a function of a function here. So let's assume that g is sine x. So y can be written in terms of g as g power 3. So dy dx can be written as dy over dg times dg over dx. Now dy over dg, that is simple from that substitution. That's just going to give you 3g power 2. dg dx is quite simply cosine x. Now substituting the expression for g, which is sine x, we get the final answer for dy dx as 3. G is sine x, but there's a square there, so sine x squared, cosine x. And that's the final answer. Let's look at the following function. Again, we can substitute y equals, say, f squared, where f equals tangent 2x plus 3. So dy dx equals dy df times df dx. Now we know what dy df is. That is just 2f. Now what about df dx? Now df dx can be figured out from there, but note that before we do df dx, there is a function within a function again. So we can write f as tangent u, where u is 2x plus 3. So df dx equals df du times du dx. Now df du is secant squared u, as we have shown at the beginning, and du dx is simply 2. Now substituting u in here, we have secant u is 2x plus 3, don't forget to square, and times this 2 in here. So this is df dx. Let's write that in here. So df dx is 2 secant squared 2x plus 3. So substituting back the definition of f from here, you get dy dx to be 2 times 2 is 4. F is tangent 2x plus 3, and secant squared 2x plus 3. And that's the final answer. Let's do sine x over x. Let's try to differentiate this function with respect to x. So dy dx, we can use again the quotient rule. So that is the numerator, and this is the denominator. Differentiating the numerator, you will get cosine x. Multiply that by x, subtract. Now differentiate the denominator, you get 1. And then multiply that with the numerator, which is sine x, over the square of the denominator, x squared. Simplifying, you get x cosine x minus sine x over x squared. And that's the final answer. Let's look at the following function, y equals 1 over 1 plus sine x. So this is the numerator and this is the denominator. So dy dx, using the quotient rule, differentiating first the numerator, you get 0, and then multiply that with the denominator, which is 1 plus sine x, minus, next differentiate the denominator, differentiating 1 you get 0, differentiating sine x you get cosine x, and multiply that with the numerator, which is 1, over the square of the denominator, 1 plus sine x squared. So the answer will be minus cosine x over 1 plus sine x squared. And that is the final answer. What about this function? Y equals square root a plus b sine x. So we can use the rule that we employed in differentiating function of a function. First, let's substitute the following for the quantity under the square root. So let the quantity under the square root be a new function. Let's call that function f. So f equals a plus b sine x. Now, a and b, they are constants. So to determine dy dx, it can be written in terms of two derivatives, dy df and df dx. Now you see that y in terms of f will simply become square root of f. So dy df is 1 over 2 square root f. We know how to do that. Df dx, we do one term after another, differentiating a constant, that's a 0. And how to differentiate b sine x? B just follows, it's a constant, and differentiating sine x will get cosine x. Substituting back the function for the expression for f, you get b cosine x over 2 square root a plus b sine x. And that's the final answer. Let's look at the following function. There are 3 functions, and they are multiplied each other. You have the first function x, the second function is sine x, and the third function is cosine x. So how do we differentiate such a function which is composed of, say, 3 functions instead of, let's say, the usual 2? We can also use product rule to differentiate this y in the way we did with a product of 2 functions. So let's start with the first. So let's differentiate x. You get 1. And then you multiply the second and the third function, sine x, cosine x, plus, now you differentiate the second function and multiply the result with the other 2 functions. And you're going to get x, differentiating sine is cosine, multiplying that with the remaining cosine, plus, now you differentiate the last function, which is cosine x. Differentiating cosine x, you get minus sine x, and multiplying this result with the remaining 2 functions, x, sine x. And let's simplify this result. You get sine x cosine x plus x cosine x squared minus x sine x squared. And that's the answer. Of course, one could simplify the second and the third terms a little bit further by multiplying the x out. So cosine squared minus the sine squared, where from trigonometry, cosine squared minus sine squared is cosine 2x. So cosine x squared minus sine x squared is cosine 2x, where the argument is twice now. So the final answer for this can also be written in the following manner: sine x cosine x plus x cosine 2x. Thank you for watching.